Hello and welcome to my Advanced Blueprints tutorial made in Unreal Engine 4.25.1. This is first video of a series where I will go more deeply into base classes of Unreal Engine and into my free components that I am distributing with this tutorial. But before we start, we need to talk about a few of the rules that you need to follow to actually start learning advanced blueprints. First of all, do not do something that's already done. Do not redo functions that already function in the game. Many beginners tutorials start with doing jump functionality for a character by launching the character in Z velocity. This is absolutely wrong. If you want to do it that way, you're actually taking away a lot of functionality that's already built inside the character class, and you deny yourself the possibility of replicating that movement. Second rule is do not do something that is already done. And many people break the first two rules of doing advanced blueprints. The third rule is don't replicate before checking if it's needed. Many times I see people forcing replication into blueprints before even running a test run. Many events trigger based on the changing of values, and you don't need to replicate the event itself. Always think about where the event should be run, and if you're not running it too much, if you're not eating the traffic too much. So if something should run on the server, or maybe just on the owner, or maybe it should run on all clients. Okay, let's jump in and see where we are right now. So this is the starting of the tutorial project that I already distributed. I've added a few more stuff. So I've added mocap online, mocap basic animations, which is a free package you can get from the marketplace, and it is permanent free, which means that I can redistribute it with my tutorial. I also added animation starter pack. That is also a free package from Epic Games, and it can be redistributed, and it will be part of this download. I also added dynamic sort anim set, which is a wonderful example for many things that I will be showing today, because on one hand those animations are made in a really good way, but in many other ways they're lacking a lot. So for example, if you have strafe walking, you don't have two velocities, you just have walking velocity. But you have IK bones, you have hand IK, you have foot IK, which means that those animations are actually very well prepared. And we'll be using few of them just as examples to showcase what we are changing in the character itself and how it looks like in game. So let's play. Right now we're in debug mode, our character looks around, he can walk, and this is basically the third person character. In general, you can jump, you can aim or turn while jumping, you can walk off ledges, all that stuff, it's all default. So let's jump into the third person character blueprint itself. Here is nothing changed, this is everything you get from installation or download. Here is just some functions I've run on the examples, so that for example these guys, they look at the player 1 pawn on begin play, and this guy is actually turning when he reaches 90-degree aim angle. Yeah. So that's it, and here's the stuff we'll be talking about today. And yeah, that looks like a lot, but trust me, this is just a portion of what this wonderful class, which is character and character movement component, has in store. There is a lot more, and I encourage you to go through inherited variables. Most of them have very good descriptions and allow you to make stuff up, like make functionalities you wouldn't believe is really simple and possible. I also made some shortcuts for inputs if we need to test anything. Okay, so first of all, let's talk about different rotation modes. That Q. Okay, let's use one of the events to showcase how this works. So we're taking Q and we're setting use control rotation yaw on the character itself to true. Once we do that, we hit play. Now we are looking around, but when I hit Q, we are snapping exactly to our aim with no interpolation speed. It's just perfect snapping like you would expect from a first-person shooter. So this is one rotation type, and this is one of the direct character rotation modes. And the beauty of it is that it's fully replicated, because the rotation of the controller, even though the controller itself is not replicated, the rotation of it is. But changing this variable is not replicated. So it means that if I change it on the client and I run it with 2 players as clients to a dedicated server, yeah, let's move this guy over here. Okay, so let's use one of the inputs as trigger event to change this value to use control rotation yaw to true. So once I press Q, I theoretically should snap my view, as a local single player. I should snap my view to the controller perfectly at every frame. Bam! And here it is, it works. This is perfectly my rotation of the controller is being copied to the character, and it still uses the aim offset. It just have an X offset based on this green line right now, and not on the rotation of the controller as it's being copied to the character itself. So this is how it looks like, but if I run it as a dedicated server with 2 players, I believe it will completely break. Let's see. Okay, let's go as this guy. So right now, on the client, even right now, we have different turns, or not even. If I press Q, now I have this snapping that we just set up, but it works only on local client. It doesn't make a difference on the server or on the remote client. So to fix that, instead of using this, we'll be using one of my components events, which is setup turn rotation. And in case of this turn rotation, we need to pick type of the rotation, which is turn, character rotation yaw, and actually the rest of the values is absolutely irrelevant for this rotation type. If we go to the event itself, what we do is we set the tag, then we set the values that, like I said, we're not using right now, and we're running a server event, and then on the server we are just setting up the same values, and there is no multicast after that. Why we are setting locally values that are replicated? We don't have authority to actually change those values, but we can. We can change those values. However, whenever we try to read those values, we are asking the server for its version of the values, and we are swapping our local version with the server one. However, if we set it locally, it is being set instantly at the moment of the trigger of the event. And then if we have lag that goes to the server, let's say 100 milliseconds, it will be set on the server, and then replication call from the server will be called to us to change those values back. However, if we are using those values in any meaningful way, gameplay-wise, like using any abilities, we would still use the values that are being set on the server. So setting them locally doesn't change anything except for the visuals. And because all those values are, well, only visual, actually, they don't have effect on the gameplay itself, we can do it like this. We can set them locally and then set them on the server. This tag has a notification, and on this rep notify, we can go here and see what's happening. So we're checking if the character is valid, if the character movement component is valid, and then we're doing a switch on this tag. And we right now are setting this value. So we're setting the use control rotation yaw, and we're turning off the other rotation types. But this is being triggered when the value is being replicated from the server back to the client. So when we set it up for the first time on locally, it doesn't really do anything. But when the server sets it up and it replicates back to us, we start moving in a different way. So now we are running this event on queue, and this should replicate. Let's see. I will hit Q, bam, and it snaps on client and on the server and on the remote clients, everywhere, instantly. Okay, and we're back with another turn possibility that is on the character movement component itself. And when it comes down to character movement component, it got a lot of incredible functionalities that we'll discuss eventually later on. But right now, let's focus on this thing, rotation settings. So what we have here is a rotation rate, and rotation rate is actually done in degrees by second, which means that if we set Z to 360, it means that our character would make a physics turn in 1 second. The use control desired rotation means that with this rotation speed applied as physics rotation, he is trying to match the rotation of the controller. Orient rotation to movement, on the other hand, means that when there is a velocity bigger than 0, he is trying to turn with this speed yet again to match this forward vector of the velocity. So let's see how it looks like here. Okay, we are now using this basically. Rotation speed is this Z value, so let's say to something pretty low, let's say 100. And the other two values right now are irrelevant. So let's play. And we're testing immediately on the dedicated server. So if I hit Q now, the character will turn to my controller view, but he will do it smoothly. He will do it only as fast as I allow it in the value I just set up, but not as fast as I can move the mouse cursor. And it is also replicating very well. Okay. Now, if we change it to rotation to movement, then now the character will try to rotate to face the direction of the movement, but he will do it smoothly. So look that he's not snapping directly to the other way I'm moving, he's making a turn. And this is also replicated. And with this locomotion I can run in circles. Okay, and let's see what I've done here. So let's do desired rotation at angle, and let's set the angle at 115, no, something lower, 90, and tolerance to 5. Okay, What now is going to happen is going to trigger this. And it looks a bit complicated, but what it's actually checking is it's checking on each frame what's the aim offset turn against the character turn, and if he should try to match the aim offset or not. So let's see how it looks. Okay, so right now I am using aim offset on X and Y, but if I hit on Y axis 90 degrees, he will start turning. And this will work and replicate to all actors. And the event itself is not being replicated, it's being run on client per character without replication, so it doesn't really have any lag between the event itself. The only thing that can lag is the replication of the controller input and rotation itself, but this is being done by the engine itself, so we don't have to worry about that. So those are the basic rotation types, and with the control of those values you can have extremely nice and smooth rotation. And there is one more thing when it comes down to using this rotation value, because this rotation, if you use any of those options, this is a physics rotation, which means that in the character you can use allow physics rotation during anim root motion. And what it means that if you have a montage with let's actually do an example. Okay, welcome back. Let's play some root motion on top of our in-place animation system. To do that, we'll use one of the anim packs that, like I said, is just an example, and to retarget all the animation at once, easily and fast, we will just delete this skeleton and replace it with the skeleton from our animation pack. However, before we do that, we'll check if it has some, yeah, it got some sockets that could be useful. And what we will do, we will copy selected sockets, and now we'll go here, go to this mesh, we'll find this skeleton, and we will just paste those sockets. And we got shield and sword 2, shield and sword 1. Okay, there they are. So now we go back here, character, delete, and yes, replace all with the one that is in directly yeah, this one, game mannequin character mesh. Replace, yes, yes, save everything, and we actually don't need this as well, and it will be replaced by this. Okay, okay, and this is not being used at all, and now we can delete the entire character folder. Oh, wait, before we do that, we have to save all. And the animation actually didn't save yet. We need to fix up redirection in the entire package. Now they're being saved with the new skeleton. And because those two skeletons are exactly the same skeleton, they will just reparent instead of retargeting, and we won't have duplicates of animations in our pack. They will run on the same skeleton. Okay, and now let's go to animations, root motion animation, and there is one animation that is a charge attack, and I think it's this one. Yeah, it's this one. And we'll set root motion, save it, this attack 07, create a montage, name it, and there is one more which is a backflip that we want. Let's see. Okay, let's make a montage out of this dash as well. Oh, wait, no. Yeah, delete. Make any montage. Dash montage, and there should be... Oh, rolling back. Oh yeah, it's this one. Let's make montage. It will be fold back, and there's a rolling 2, but we want rolling front for something else, and this is also gonna be a root motion. And create montage, and we call it roll front. Okay, so let's take all 4 of those, open them up, and okay, I'm not quite familiar with this view because I used to be working in 424, but I see that the montage group is here, and we got already 2 additional slots, which is the upper body and full body. We will run it as full body, save it. Dash will be running also as full body, and we need to go to this animation, save it, and this also will be full body, save it, and this will be same, and we forgot to trigger that it's a root motion animation. Okay, yeah. So let's get back to our character, and now on E we're going to play montage in this skeletal mesh, and montage to play will be dash. Start section none, starting position from the start, play rate is 1, and that's it. And if we run it on server, it will actually break, so let's test it on offline client, and E. Okay, that pushes us forward just as we wanted. Okay, so let's now run it on multiplayer. Okay, let's do it like this, run on server, reliable. Okay, and we will do basically just, no, we can't do it like this, but we'll copy this, make the same reference here, montage to play is the same, and yeah, like this, and then multi montage play, and this is multicast. However, on multicast we need to do a branch, not to run it twice on our owning client, which means that we need to check if is locally controlled, is player controlled. So if it is a local player, true, then we do not want to run this event. But if it's not, then we need to do, well, basically the same. Okay, so let's take all this a bit to the side, C, and let's do multiplayer montage. Okay. And now if we run it on dedicated server as clients, and we run it as this client, it doesn't play on the let's see, what did we do wrong? So E, play montage, the montage is playing, then we push it to the server, server is playing, that is actually moving the character, and then multi, oh, okay, yeah, false. If he's not a local player, then we play the montage, yeah, that was the problem. Yeah, that's gonna help as well. Okay, yeah, now he's playing correctly, and he doesn't have problems with correction of position between server and the client, really. So right now the character is doing the Q event, which means that we are rotating only if we are moving or we hit the 90-degree angle. So if I hit dash and I move my cursor during the dash, I will actually just look on the side that I would like him to move and nothing will happen. But if in the character movement component I allow physics rotation during root motion, let's save that and run it, now I should be able to actually change the direction of my dash while dashing. You see that? And it is not instant. It would be if we made the first turn type, but in this solution we are still using aim offset on the dash. Let's do one more thing. Set custom time dilatation about global time dilatation. Well, what's the difference? Okay, yeah. So 0.1, and set it to 1 on uncompleted, and we do the same here, and we do the same here. Okay, on our clients. So now I can see that I am turning, moving my aim offset while I'm doing the dash. Of course, because of the server position correction, you should never, absolutely never do a changing of time dilatation on client and server. But this is just to show a bit slower what's happening. Okay, let's delete that. So this is working. We can now run any montage with this. So let's do something different. On Q, we are changing the rotation type, and we are changing the rotation type now to rotate to movement. So we're going back to directional moving. There is no strafing, and once I hit Q, I walk in circles. Everything works as last time. When I hit E, I don't really have the control I just had, because right now I am moving toward the velocity and I am turning toward the velocity, but the velocity is being declared by the root motion. So if it is a dash in straight line, it doesn't matter where I'm aiming at, I will be aiming while dashing, but it doesn't change anything. I'm still dashing forward. So what happens if we actually do a different montage, which is a volt back? So let's change this for a second for character rot yo, or even no rotation, just to show what we're doing here. Play. Okay, Q. We don't rotate at all right now, and when I hit E, I will do a volt backward. Nice flip. And I can look on sides, but I will always do this flip. By the way, the aim offset works a lot better than I thought, even during something stance like that. And it's overriding any movement inputs I might have. However, if we change the rotation type to rotate to movement, now something funny will happen. Okay, so we're looking forward, we were moving forward, and now we're doing a backflip. And oh, okay, so now when we're doing a backflip, during the motion, we can actually turn our aim, and it will try to move the backflip with the speed that we designed to match our aim. So we can actually change the direction while moving. And this works the same for any other of those physics root motions, so for physics turns. So for example, if we do desired rotation, so this is the strafe walking that is trying to target as fast as he can my rotation. When I hit E, I will automatically backflip and try to match the rotation. So I can turn the flip while doing it and doing the aim offset while I'm doing it. That's pretty cool, right? Okay. So those are the rotation types, and this is what you can do with allow physics rotation during root motion. And like you can see, it works on dedicated server, it works in multiplayer, and there are no problems with that. And it looks pretty cool. Okay, let's go to the next part. Jumping. Many tutorials that are trying to be intermediate advanced tutorial. They're starting off with making a custom jump. I have no idea why, honestly, because you got all the jumping functionality you could ever dream of. So first of all, you have the jump count, so you already have multiple jumps. You can do 2 jumps, 3 jumps, whatever you want. You have the jumps max hold time, which is a bit more tricky because this is applying force on tick, but it is actually taking a toll from your frame rate. So it is a bit adjusting, but it can give different results on different frame rates. So it is not as consistent. You can always check how high your character can jump with reading some values, but we can go to that. So what we got in the character class itself, we got the max jump count. Changing that is well, obvious what it will do. It will allow us to jump twice, and we don't have to replicate anything. It just jump and jump, and it just works. Out of the box, it is being replicated. The jump hold time allows us to hold the jump button longer and allows us to jump higher or not as high depending on how long we are holding the jump button. And it's actually just applying force on the Z velocity, but it is more than that. And let me explain. Because this is all you have to set up in the character class. Let's set it back to 0, but in the character movement component, wait. Yeah. Okay, yeah. In the character movement component, I clicked the wrong component. In the character movement component, you have a lot more settings, and those are the settings that the tutorials never actually touch. So, for example, you have air control. Air control boost multiplier. It's like how much extra air control you have as long as you are applying velocity. I mean, you're applying force. You have the braking, deceleration, falling, so you can actually increase or decrease the falling deceleration while jumping. You can impact the velocity you have or override the velocity that you have. So on jump, you can, for example, if you're falling at very high velocity, you can stop this falling movement to do the jump. One of the examples that Destiny used that. So you can, at many jumping puzzle, you can fall really fast and really low, but as long as you can hit jump before you hit the ground, you will start the jump again and you will get fall damage based on the location where you did that jump. And there's the obvious can jump, which is a toggle value. And it is very important because, for example, for my example with the Resident Evil mechanics, I don't allow the character to jump. It's more than just running the functions. I just don't allow it to jump. So if it is by any chance at any moment falling, like you see here, it means he's literally falling. So he's fallen from some obstacle. And for example, we can do ragdoll based on that. So can jump is reading this value. It's a character function. Is jump providing force? It's another value you can read, and what it means is that if right now you are jumping intentionally by pushing the jump button, or you are actually falling because you've fallen off an obstacle. You have two very important events: on jumped and on land, and we could do something cool with that actually, just to showcase. And let's do it like this: custom event, client montage play. Okay, and it's this, and now we're forwarding this, and okay. Okay, so we haven't fold back, or we can stay with the dash. So we haven't changed the E functionality right now, but we will do event on landed, and we use this event, so client montage play. Okay, and we'll do a roll front. And that's it. And what it will do is that now our character, when he is jumping, when he lands, he will do a roll. Every single time on the server and on the client. And the fun thing about that is that actually we could just do this without replication. Run it, So there's no replication to this. And right now you see it triggers and it actually moves us, but we don't see the full animation on the remote client, but the motion itself is being triggered on the server, for example. So let's go back to this. And let's say that we want to play this only if we actually no, this is fine. So for okay, so yeah, this event allows us to run different logic when we land, and we can do custom gates and logic, or we can actually do I don't know, switch on gameplay tag, and here we can make different cases and do different logic based on state and context of our character itself. Okay, going back here. On jump, that's an obvious one. For example, we want to run sound when we are jumping, or we want to something to happen, run particles, make noise notification for AI pounds or any other logic. We no longer have to do on jump input, jump, and then do something. We can just trigger it here, and we don't care where the jump starts, because this function, jump and stop jumping, it can be run from the character, but it can also be run from the controller, or it can be triggered by an ability. So if an ability triggers jump function, it will not trigger whatever we program here inside the character, because abilities cannot trigger player inputs, but it will trigger an event, which is event on jumped. So when we jump, we could play sound or do something that I don't have resources in the project to actually make an example of that. Okay, let's get back here. So jump and stop jumping. Basically, stop jumping always triggers when we land, no matter what, and jump, as long as we don't do stop jumping, is applying force as long as the jump max hold time is greater than 0. This is a very cool event built on reach jump apex, which we can actually run inside the anim graph. So we can go try get pound owner cast to character, or we can just use the character reference that we, I think, have. Components. Oh no, we don't have the character reference. So we can just cast pound to character, and from here we can do bind even on reach jump apex, custom event, reached jump apex. And if we run this on basically begin play of the animations, which is the event blueprint initialize animation. I got some events that I'm not using right now. I'm actually got this example. I also got event on hit. We can do stuff from here. So if we bind event on hit, it means that whenever we get a hit event on the actor, we can do hit additive animations running on the character directly in the anim graph based on the hit direction, for example. And here on read jump apex, if we got, for example, 2 jumping animations, which one we would like to use for ascending and the second animation for descending, we could actually do that here. So instead of this animation, we would make a state machine, and in that state machine, based on a value, we would go from one animation to second animation and blend them with inertialization. It would look a lot better. I will actually make an example of that later on. So this is basically jumping, however there is more to it. You have vast number of control over the jumping, and you even can not apply gravity while jumping, or you can apply just a fraction of gravity while jumping. You can notify Apex, which is clothing system, that the character jumped, and it's reacting differently on great difference in velocity. Suddenly it understands that you jumped, so it shouldn't go wild. Next example is quite similar. It's about crouching. You got crouch, uncrouch. This is actually very easy to trigger, because you can just branch depending of if the character is crouching right now. So if he is crouching, then uncrouch, and if he is not crouching, then decrouch, and you have a toggle. It's simple as that. Can crouch is another value that you hold from here. From movement. So can crouch, by default it is off, and when you are crouching, some things happens. The capsule is changing the size. It's also changing the eye height of the character, which is something I will explain later on, and do a small example about blending the camera when crouching, if we don't want it to be too sudden movement. And once again, we got on start crouch and on end crouch. And why do we need those events? If we have those events, crouch and uncrouch, we can do stuff behind it. Once again, we can trigger crouch and crouch on ability, but ability will not trigger the input, so it will not trigger the entire chain of things we want to do. So the chain of everything that is going to happen after crouching should be done here. So for example, even on start crouch, we would play a montage of idle to crouch, for example. We can play animations, that is a transition animation. We can, for example, make our character stealth, invisible when crouching. We can do a lot of gameplay stuff right here. And this is basically just reading the value of the crouching half size. Where is it? Yeah, this crouch half height. If we scale the character entirely, so the scale of the entire actor in word space is more than 1, then this will give us the scale multiplication of this value automatically. There goes crouching. Those are very important events on Posses and on unpossessed. This is events that you would want to trigger and establish some UI or some other local references inside the character to the controller itself. So if, for example, you hold up your character inventory in the character itself, you might want to make a reference to that inventory to the controller, so the controller knows that when he's running any inputs on the UI, he's calling on the inventory on this new pound that he's possessing. On unpossessed, for example, you could want to add an AI controller to the character and make him an NPC because a player quit the match and his character is becoming a bot. Okay, event hit. Basically, any actor got an event hit. And what it means is that the root component of the actor must have the generate overlap events. and simulation generates hit events. So the character as an entire thing, the capsule, is simulating physics. So the gravity is taking up hold of the character can collide with physics objects, and in most games you see that when the character is colliding physics objects, they are being moved by you like they were made out of paper, but it's all due to settings of the mass of the character itself. But even simulating chair or a table could stop your character from moving if the physics settings are properly set. But when you hit another simulating actor, you will trigger this hit event, and you can, for example, make animations based on what you hit. You can make the character lean to avoid some obstacles, or touch a wall that you just touched with your capsule and place a hand on it. You can do a lot of stuff because you can tap into the information, like what components, for example, the mesh component or the capsule component, touched other actor, and what component of the actors. For example, that would be if the actor is static mesh actor, then the component would be a static mesh actor component. Self moved would mean that we got moved by physics. Hit location is the exact location point. Hit normal is the angle of that location, and normal impulse, I don't really know what it does. It's a typical hit. If you break it, you have everything you have in hit. So obviously traces will leave nothing, but you can push this hit structure directly to some other events that will do something on the other actors. For example, this actor could implement an interface of being hit, and you can run an event and you can push the hit information about where we stumble upon it, and you can do something. Okay. Update custom movement and on movement mode changed. So right here in this example, I am doing some stuff when it comes down to changing locomotion type, and when you go directly to the anim graph, you can see that I am taking the movement component, movement mode, which is an enumeration, and I am doing a switch blend on this mode, and I am using the default pose, walk pose, and nav mesh pose to use my saved standing base locomotion pose. So I'm just making this the base layer system, where you have the upper body blend and full body blend, adding the IK on top of it, correcting of the hand position, and saving a pose. And this pose, even if I am blending between this and this, it's not calculating the animation twice. It's just calculating it once, and it doesn't hurt. But I can directly here add other poses like swimming, flying, none, the default one, and custom. And for custom, right now, I have just a pose snapshot of ragdoll pose, and it gets overwritten by a full body montage, which is used for get up montages that I haven't implemented yet. But just to show it, let's say that X will take my component and it will go ragdoll, and it will is ragdoll. Check if it's ragdolling right now, and if it's true, then stop ragdoll. Make later pelvis. This is the bone we want to doing the ragdoll on. However, if it's not ragdolling, so false, we want to start ragdoll, use the same bone, and physics blend weight would be 1. Okay, so now on X, we'll ragdoll. And you know what? Actually, we'll do it correctly. Bam. Okay, and disconnect this one. So now on X, we're doing this event because we will be using this event later on. So this is, well, not trigger, it's actually toggle. Okay, let's just test it on local for now. I will fix it in a moment. Target input name, make literal, pelvis, plant physics 1. Okay. Or let's test it now. It's a dirty fix, so I will have to work on it. No, it's not working. Okay, let's just test it locally. Okay, so yeah, okay. Yeah, and I cannot move when I'm in ragdoll. I get up. So, and can I play root motion animation? Yeah, but I am actually in custom movement mode. So even though I'm playing the dash animation, it's not moving me. Why is that? It's because I have set up maximum movement speed is 600, but in the event itself, in the ragdoll event, I'm disallowing the movement of the character. And also I am not running any animations because I am entering a custom movement mode when I'm in ragdoll. And on this custom movement mode, I can actually trigger different locomotion types. So on custom, I could have ragdoll and I could have, for example, climbing. And on climbing, I would change a lot of functions to move on a plane that is based on the angle of the wall that I am climbing right now. So this is where this comes in. I can save the previous movement mode, and there is this event on launch. So whenever you're doing launch character, this will trigger. So this is the same like jumping and crouching. You have the crouch, uncrouch, jump, unjump, and then you have those events on start, on end. However, when it comes down to launch, it's something that you run on tick, so it just triggers every time this triggers. So if you are launching multiple times in a row, this will trigger multiple times. But you can also do once and at some point do a reset. If you want something to happen on launching only once a while. Okay, let's go forward. Even on become view target and event on end view target. So let's not get confused. This is different than possess and unpossess, but in many ways it is similar. Becoming view target, like set view target with blend from character controller, means that you are switching view between actors, which can be basically any actor. It can be a static mesh box that it's not a pawn, it's not a character, but it also has eyes viewpoint, which would be located at its root, and the rotation would be just the forward vector of the actor itself. But character is a bit different. He has values that set up where is the eyes height. So what this means is that when you take the capsule component, which is 88 centimeters, 100, I mean, it is 88 centimeters in both directions because it's from the middle out. So 172 centimeters on default on this from here to here it is 88, and on 64, so around here, is the eyesight of the character. So it doesn't matter how the mesh moves. This is just how the root of the actor itself, which is here at the arrow at the center, is being moved when it comes down to eyes height. Why this is important at all? Well, for example, we want changing the view target is one of the most obvious things that we want to set up the eyes height if we don't have a camera in the actor, because if we have the camera it will just trigger the default camera that is active, that it has set active. Now this is out activated. But if we even delete this camera, it will set up the camera from the character controller, and it will snap that camera to our eyes height. And if we crouch, it is obviously changing the eyes height. And let's do something about that crouching. So on 1, we'll just do pressed crouch. Crouch, and on release we'll do uncrouch, and it's automatically replicated. We could test it on multiplayer, why not? It's client, and what it will actually do for us, as we're not changing any animation, it will just show collision. This is our collision. And when I hit 1, no wait, what was it? Yeah, 1. Oh, okay. Stop. Character movement. Crouch. Can crouch. Yes. Okay, now play. And when with this character, I play. Click 1. The camera is snapping terribly, because show collision, it is changing the height of our capsule to extremely low values, and the camera is routed to this to the capsule, not to the mesh itself. So what we want to do, we will take camera boon and we will see if it enables lag. No. Okay, so let's enable lag, and let's make it 0 on default, but set lag. Okay. Then delay 0, and do the same here. Bam, bam, and we're not going to pin it here. We're going to do it here. So on start crouch, on end crouch, and this is part of the crouching mechanics. But this will trigger no matter where we trigger those functions. This is what they are for. And I forgot to pin in. Yeah, okay. Bam, bam, run. And now the camera shouldn't snap as badly. You see? It actually blends real well. And changing that was that simple. You don't have to do by hand interpolation of the camera position. You don't have to do something on tick. God forbids you running functions on tick unless you really, really need to. You just change the camera speed, and now the speed is again instant, but only for those 0.2 seconds that you are moving, crouching, it's slowing down. And also the camera actually snaps when we are moving on the stairs, and we could do this as well when we are on the stairs. and trigger similar camera behavior when we're working on an angle. So we got crouching and crouching, hit, we already discussed this, launched, actor eyes height. Like this value is really useful because you can read this value directly from the character class, and if you have an AI, if you use the get AI controller, and we got a function called set focus, and we set focus to this actor for any AI, he will actually he will set the control rotation from the eye height of the capsule of its pawn, of its character, and the target of this actor will be the root. So basically he will be, when walking next to you, he will be looking let's go here. He'll be looking at your junk. You see, he's when we're really close, he's looking down because he's looking at the center of our capsule, which is at our waist. So it's a bit creepy. However, if we would have a different character, or we could do a switch that if it is a, oh, we can actually do that. We can actually do that here. We're checking if we are an AI. So if we are AI, set eyes base eye height. Okay, and we'll set it not at 64. We'll set at 0. At 0. Our AI will have his eyes at the root, so directly where the arrow is. And let's run it just locally because I didn't do replication for that. And now when they all focus me, if I come really close, they will be looking me in the eyes. And they're not really looking me in the eyes, they're just looking from their waist to our waist. And this is how they're calculating the aim offset. So this guy will actually look a lot lower than is our eyes, but it's almost the same. And for our aim offset, you can see 3 lines being drawn. The red is the actual line trace of our camera. The purple one is the weapon aim that is being used when we are doing aim offset as aim. And the green one is our head tracking for look at aim. So we are not using our eyes height. It's more for AI. We are using our actual direct head rotation for better aim offset, so we don't target with our chest at things. Okay, let's go back here. So this is how we can tap into those values, and we can always check the rotation and location of any actor's viewpoint. Okay, one of the most important things about Unreal Engine is its amazing damage interface. And many people are doing damage but by their own interface, and they're doing check that when you hit something, does it implement my damage interface? And if it does, then send a message. Why? There's already an interface that works on absolutely every object in the game, and every actor base class implements damage interface. It is fully replicated. It is also fully secured that damage can be instigated only on the server. However, when it is instigated on the server, it triggers a lot of events. So, for example, those events are being triggered here in the actor. If anyone deals damage to us, like any damage source, we can, for example, do an animation that we got hit, and we know how hard we got hit. We know what damage type it was, so if it was fire damage, we can apply some particles or do something, or do a damage reduction, because this is implementing how we are receiving the damage, not only how we react, but how we are implementing the damage. So if we have health system, this is where we would reduce the health. And if the values are being replicated, this is being triggered only on the server. So only the server is reducing the health, only the server is doing all the relevant stuff, and from the server we can do a multicast that is doing the visual stuff on every receiving character. But this is great for reducing health, doing general stuff, where, for example, point damage, we can also get a bone name, do critical hits on, for example, certain bone names. In the Resident Evil example, I have stagger on hits of legs and head, and double the damage on hits of head only. And I am using this event to check what's actually happening. We also got an information like where from is the direction, what is the hit normal. So if we got hit on the head, we know at what angle it was, so we can spawn particles of a hit at certain angle, and we got the entire hit information is being pushed forward. And on radial damage, we also got a hit, because the radial damage is being done at the moment of the nearest trigger. So if we got multiple components, if we got a very complicated actor, a radial damage will deal damage to us only once. It will deal damage to the nearest component that receives damage. And yeah. So if we spawn and do radial if we do apply radial damage, which is also protected and can be run only on server, let's say do damage 10, origin would be somewhere near our actor and radius would be 100, the hit would be the closest point between this origin and the actor that is in range. Okay. We also got the damage causer, and the damage causer is the actual actor object that is dealing the damage, and from the causer we can get instigator, and we can get the instigator controller. So we can get, for example, if we got damaged by a rocket launcher, so it doesn't matter, it might be an explosion, it might be a trap, it might be a bomb, it might be anything. If we got damaged by any source, let's say it was an actor that is a mine, this actor was set up by some instigator, by a controller, by a pawn, and we can always tap and see who's the owner of this actor and who is the instigator controller of this actor and who is the instigator of the damage itself. So, for example, for a rocket, the instigator would be the rocket launcher probably, but the instigator controller would be the controller of the owner of the rocket launcher, the actual user that is being pushed down through those events. And we'll work a lot in the upcoming examples with damage system, as we can do a lot of really cool stuff with damage types, which is also another amazing thing that I can't go in deep right now. But yeah, look forward to doing more stuff about damage. And last hit by is also a very nice thing. Like, for example, if our character got damaged by multiple enemies, and in the end he got pushed back by force effect of an explosion, fallen into an abyss, and died by falling. Still, we can listen to what controller did the damage to our character the last. So we can know which instigator controller dealt the last damage that was an environmental, and he could get the kill, experience points, or assist, or whatever, based on that value. And there's also an event on instigated any damage. And instigated any damage means that we didn't receive damage, we actually dealt damage. So for example, if we dealt damage, we could spawn an actor or spawn a widget that is scrolling combat text, and we can display this text. And this is important because we don't want to run things like that on replication on the server. We don't need this to trigger it, because this is being run locally. We just bind this event, and when this happens, so we instigated any damage, this triggers. And this event, bind event on instigated any damage, can be also set up in the controller. And in the controller, the player controller, there's also another one that allows you to bind event on pawn receives any damage. So it doesn't matter if we control a character, if we control a helicopter, or we control a boat that our character is sitting at, we can always display combat text, and we can always get some information that, for example, if we receive damage, then we should update the UI when it comes down to our health with the new damage value, the new health value. Or if we dealt damage to someone, we want to, log the number of damage that we dealt, and after the combat display a sum up of the combat on how many damage we received and how many damage we dealt to the person that killed us, for example, like it happens in Counter-Strike. Let's go to character movement. This is an absolutely incredible stuff that we'll go through right now, and then we'll go through all the functions that we have here, all the values that are really amazing. So the character movement, what we can do. If we are doing a completely custom movement, we'll run the function consume input vector. We'll override it because normally the character is using this function to move us by character movement component. So what, for example, ILS version 4 does, the free locomotion system that is forever free on the marketplace, it is customly consuming the input vector, and based on this input vector, it is setting a lot of variables like acceleration, deceleration, movement speed, everything based on that input vector. And we can always tap into the last input vector or pending input vector. Why this is important? It is important for root motion. Now you see this is the default that you get with third-person character, and movement input is basically taking the axis of the input and is adding the movement input scale value, which is between 0 and 1, and it is being chopped down to in between -1 and 1. Okay, so instead of on input setting some two float variables that you would have a input forward and an input right left, and then using those values to run our root motion controller, we could actually do it as it is right here. We could set up the animation settings to class default to root motion from everything, which means that we just take root motion for any animation we have. So if we have idle animation on default here, it doesn't matter what we have set up in the character movement component. If we have an input and we have a maximum walk speed of 600, it doesn't matter. If we are taking root motion from everything, we will be standing still. But we can take this vector and break it apart in the anim graph and use it for our we can use it for our blend space. And on the blend space, we can go from idle to the blend space based on the pending input vector being more than nothing. And it is very important that when you are reading those values from here, from the character, both of those values will give you a value between -1 and 1. However, if you are reading those values from the animation blueprint, you see the animation blueprint actually triggers after the controller, but before the character itself. So if you have, and this is funny, like if you have this add movement input, not here in the character, you have it declared in the controller. Here in the anim graph, if you read any of these values, it will give you a value. But if you got input value here, if you read those, the pending value will be 0 always, because it got already consumed. And the last input value will give you the actual input value of this frame of animation that you should use. Okay, this is the previous frame velocity. Oh, and this is also very important value. Like those values, they're not that important. They are important if you have really wild values when it comes down to acceleration. So, for example, instead of having 2000, I would have 100, and that would be ridiculous. So I am accelerating really slowly. To get my 600, I need 6 seconds to actually reach my max speed. But when I'm turning, I'm actually losing this acceleration. So it's actually not so bad. Okay, where we are here. Okay, so those are less important, but they are multiplication of this by the acceleration and maximum movement speed. But this is very important. For example, you want to do fall damage. So what you do is you get velocity of the actor and you compare it to the velocity of the previous frame, which you can read directly. You don't have to save a value for that, and you don't have to save this value on tick. It's already saved, and it's already a C++ function, which means that it's a lot faster than whatever you can do in blueprints. And you can, you know, check what is the length of this difference, and if it's above certain value, that would mean that you need to receive damage, and that would mean that you, for example, fallen from very high and stopped rapidly, or you were moving at extreme speed forward with a car and you hit a wall. And that will be the difference between those two vectors. But of course, you can also break both of those vectors, and you can just take the z velocity and see the difference between them, and you can do absolutely the same here and check if it's above certain value, and also do just falling damage. You don't care for forward acceleration or right acceleration, but actually you should, because like falling down and getting damage is the same as being launched forward from a cannon and hitting a wall. You also should take damage. But if your design is by checking just the z velocity, it's fine with me. It might be a gameplay decision, not a realistic decision. And I personally believe that gameplay goes first above realism. You shouldn't aim for the perfect life simulation. You should search for mechanics that makes the game fun. Not, just subverting expectations or making players miserable. Okay, so these values change per frame. So for example, if you fall from a very high and you get great acceleration and great velocity, if you fall into water, you will decelerate at a rate. You will not just stop moving. So you will get less fall damage if you fall into water than if you would fall on a solid ground. So this is how you use this value. Don't forget about it. That it's already done. You don't have to store it yet again. Okay, from character movement, you can also read the current floor. And from the current floor, split structure pin, you can always know what's the distance to the floor from the center of the actor, what's the direct line distance, what's the current floor hit result, and from this hit result, you can, for example, get the hit normal, which is the angle, and you can compare this normal to normal of our character, and if the hit normal is at an angle, you might want to do something about it, because that would mean that you are walking up the stairs, down the stairs, or down a ramp. So you can always read this value here and recombine. And you can obviously from the floor you can get the oh wait. Okay, from the hit result you can get physics material, and you can get the where is it, type, surface type, yeah. So you can, for example, always check the surface type, and you know, for example, on landed, where's jumping? So when we land, we might want to check what we land on, and based on that hit result on landing, we could make the landing sound based on the surface we landed on. And we don't have to do a line trace every time we land and do it customly. We just read values that are already here. So this is the main principles I made, number 1 and 2. Don't redo something that is already done. Oh, and this is also very important. Now, we'll just do it in locally, yeah, offline, 1. Okay, so you can see that when I go to a ledge, I will basically levitate, because my capsule components actually still get traction from this ramp, and it doesn't care for the animation and for the mesh. When I move a bit more, okay, yeah, I was barely catching with just a barely. It still didn't allow me to fall. So why is that? It's because of this setting, perch radius, and it's on movement component. No, it's on the character, I think. Yeah, movement component, perch radius, threshold, and height. Okay, those are the 2 values that we need to focus about for a second. So perch radius means that how many centimeters, units, from the edge of the capsule we can grab onto surfaces and not fall down. So the capsule is 42 centimeters wide, which is a lot. So if we go to the movement, and we'll set the radius to 22, which is half of the capsule, look what will happen. Show collision, and now move. Oh, and we're fallen. You see? I went to half between the middle and the outside of the capsule, and we've fallen. Okay, but this actually works in another way. We have a value that is called walk off ledge. So can walk off ledge, can walk off ledge when crouched. And we'll get to this in a second. So let's say that no, we can't walk off ledge. If we can't go walk off ledge, it will mean that when we hit this threshold that we will be falling down, we will not be able to move forward. So the game will stop us from falling down. But let's say that on crouch, we can walk off ledge. So, or let's do the opposite. We can walk off ledge, but we can't when we are crouched. Okay, so I'm holding 1, I am crouched now, and I cannot walk off ledge. I will bounce from the ledges. No, nothing will happen. But if I let go of 1, bam, I can immediately fall down. And we can make this value as high as the capsule width. And right now, if I hold 1, I can only go as close as this to the edge. And it's impossible for me to levitate even, okay, I can levitate with 1 leg, but this is maximum I can do right now. And it is doing one more thing. It is checking for step height, which is also set up in the, we'll do it in a second. So something that is checking how high between, how high vertically we can step up on any object. So any box, any cardboard, anything like those stairs, we can step up only if it meets this value. But when we have the perch settings, it's actually adding some value to it and allows us to, see here I can't walk off ledge, but here I still can walk off ledge. It's giving us an extra tolerance of walking off ledges. And it's the second value. This value gives us the additional tolerance, and this is being added to this. So 95, so 45 plus 40, is the maximum height that we can walk off ledge while crouching. However, if we lower the max step size to, let's say, something ridiculous, 5, we shouldn't be able to even walk here. Oh no, I have to lower it even more. One. I don't know if it can be more ridiculous than that. Oh, we're still walking upwards. Okay, but we're falling downwards. So the angle is too much for us. Let's put it to default. So this perch value is very important. That allows us to walk off ledge and not, just be in midair. And what cool we can do with that? We can actually make an event which is on walking off ledge. And on walking off ledge, we can, for example, start climbing. If you are crouching and you allow walking off ledge when crouching, you could go directly to custom movement motion, custom movement type, and start climbing on the surface you just were on. So you know where you were when you started walking off ledge, the previous frame. You know the previous location of your character, and you know how much time it has been since you've been in this location. So you can run, you can, for example, make your character turn towards this location to make contact with the wall that you want to climb, and start climbing and catch the ledge with IK. But we'll do something a lot simpler than that. We'll just ragdoll. Oh wait, we got an event here. We'll just toggle ragdoll. So if we walk off ledge, let's get up. However, if we jump, we are still jumping and we are landing. Bam. Bam. Oh, let's, for example, we could make this roll on landing. Okay, let's not get distracted too much, but just an example, we could make this landing condition based on our previous frame velocity. If it was, okay, let's do it. If it was get vector length greater than, and I have no idea what the velocity will be at our landing, let's say 300, no, 300, not 3000. Okay. Yeah. Bam. Let's see, so if I land like this, okay. Let's make it more. Let's make it more than that. Let's make it 1000. Okay, yeah. Now when I jump in place, nothing will happen. But if I jump from up high, okay, still nothing happens. I don't know what's the velocity. More than 600, but less than 1000 apparently. Yeah. Okay, so right now, if I jump while running, I will roll. If I jump in place, nothing will happen because my velocity is not enough. But if I jump running, I will roll when I land. If I hit Q, I actually can even change the direction of the roll while moving. And if I walk off ledge, oh, ragdoll. Okay, let's get back to it. Okay, and now we're getting to the jumping that I started with. I said that why do people do custom jump? Why in the hell when you have all the functionality of a jump here? And the simple answer usually is, oh, because I want the jump to be exactly at the height velocity on blah, 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 that I want. Well, you can still do that, and you can actually run a calculation. Let's run it on 2. That's saying that if I want to jump on 200 centimeters, so 2 meters, it will tell me what should be my Z velocity. Let's run it. 626, and right now I can jump up to 90 centimeters. But if I set it to 626, my Z velocity, I should be able to jump on 2 meters. 626, okay. Jump velocity 420, 626. Okay, yeah, let's try that. 199.93. So yeah, that's very close to what I wanted. So I wanted exactly 2 meters. So let's see if I can actually jump on something that is 2 meters high. Let's place a cube here, which is 1 meter cube. Let's place another cube on top of it. It doesn't have to be straight. And snap it. Okay, so that's 2 meters. Play. Let's go to those guys. And let's jump on top of them. I'm barely not catching the edge. So let's increase the velocity a bit more, 630, so I'm sure that I am catching the edge. Yeah, I should be able to jump on 202 centimeters. But what is happening is that my perch settings right now are too high. Yeah, because I got 44. I need to lower that to, let's say, 22, half. Because as we land, we get the fall of ledge instantly. Okay, yeah. Now it works. We can jump on top of it. And actually, I will lower it a bit more. 10. Okay. And now my jump height is exactly as I wanted, and that was a very simple calculation that I am sharing with this blueprint. So you can always check for your desired height. And the great thing about it is that you can change the gravity scale for your character, and you can then counter change the gravity scale for just jumping. And you can also verify that if you change the character's jump hold time to, let's say, 1 second, which is extremely high, we can read the value like how high we will actually jump now. And it is 832 centimeters, so 8 meters. Yeah. And that's exactly as high as we are jumping. And with this high jump, we will always roll, basically, even if we jump in place. Yeah. Okay, we're not done yet. This is getting fun. Now, what can we tap into directly from anywhere? So what is part of a library that you have on default here? So from this actor, you can get the controller, and you can obviously cast controller to AI controller, for example, or cast it to player controller. But you can also just check if it's player controlled. If it give you true or false when it's player controlled, it doesn't matter if it's on server or locally. You can check if it is locally controlled. And remember that all AI are being locally controlled on the server. So this will return true for any AI. So if you want to check if this controller is for sure AI controller, and run this function without casting, and casting is expensive. Casting is actually making an object extra one more time in the memory, and it is comparing the object that you cast to with the object that you have. So it's eating up RAM. The more cast you use, the more memory you will use, and the bigger your actor are, they can be few megabytes big, the more memory you will eat up. So you can check if it's a player controller, and then you get controller and get player, get AI controller, for example, and get player controller. And you can do directly stuff that you would do on AI controller. So for example, focus. Set focus on some target actor. And you can check it like this. So player control and local controlled is local player. Not player control and local control means it is an AI for sure. Or you can just read the value is AI controlled. Is there something like that? No, unfortunately not. Would have known. Yeah, but you can check the player control. Um, okay, you probably know this function, get player controller, and you probably abuse it actually a lot, and get player controller, and then you do stuff from this player controller. But you can actually get player pawn directly, and it will return you the player index 0 pawn, or you can get player character directly. And what you have here is a character object reference, which means that from here you can go set jump max count 2 directly. You don't have to cast this to other object because it's already a character and this is already a pawn. So you can, for example, check if is locally controlled directly from here, and you can run this function from anywhere in any blueprint. And you can also get the player camera manager, and camera manager is a different story. It's very useful as well, and you can, for example, set view min and max yaw, for example, and you can limit the up and down aim offset from the camera player manager, and that will affect the controller itself. You can also tap into player state, just get player state, and player state is an incredibly important function. I will go through the game mode, player, controller, player state, game state objects, what they do, why they're important, why you should use them and start using them in every project soon. So from here you can check if this player is a spectator or a bot. And this is a variable run from the pawn, so it is relevant for this character. So this character got a controller, this controller always got a player state, and this player state saves a lot of values that are important, like the name. Bam, you can get the player name and you can display it somewhere directly from the character. So you can get player pawn, get player state, get player name, and you can run this, and that, for example, from the UI. And there's a lot more functionality to player states that I will go through later on. And there's the game instance, which is also another tutorial, game mode, and game state, and obviously the controller. And there's also two functions that you can run to get game bundle ID and get game name, which is reading from the ini files. And based on that, you can identify the platform. But you can also get the platform name directly. And any actor at all got an owner and an instigator. And the instigator is a pawn. So it is, for example, instigator of a rocket launcher would be the guy who is holding the rocket launcher. And the instigator for the rocket would also be the guy who is holding the rocket launcher. However, for the rocket, the owner would be the rocket launcher, and the rocket launcher's owner would be the pawn. And the pawn owner is obviously the controller. That's why we locally can run on server events locally, because we are the controller and owner of this class. So that's it. This is just some functionalities of the character class and movement component. There's a lot more to it. You have just a lot of values that I really encourage you to play with, and the character as a class is just incredible. I see like a lot of people are saying like, oh, how to do crawling. Well, just use a different movement state, or that you can do a custom movement state, and you can do custom rotations, and you can do physics rotation, you can do a lot of stuff. Or you can use crouching state as your crawl state, and it will be it will be replicated by default. So that's also cool, right? And by just setting up a lot of values, you can adjust the states to your liking to do exactly what you want them to do. Okay, so let's sum up. Just few things we done today is that this guy can walk off ledge and he will trip unless we jump, and if we land with certain velocity we will do event on land, and we can also dash, and this dash can change direction because we are awesome and we're doing aim offset while dashing. And we can ragdoll whenever we want, and we can also fool around. Okay, yeah. So that's it for today, and I'm working on further materials. In the next tutorial, we will be adding more animation states because right now we don't have we're taking the forward velocity, so only when moving forward we see animation, and when we're turning we're more of an idle because the forward vector is lower. So we'll set up a lot of more multiplayer stuff for the next tutorial. See you guys soon.